nature does not care about beauty. Evolution is not an artist. It does not produce color for the sake of color, or pattern for the sake of pattern, or iridescence because iridescence is pleasing to look at. Every extraordinary feature in the natural world exists because it solved a specific problem. Finding a mate, deterring a predator, absorbing light, or signaling health to a potential partner, evaluating thousands of tiny biological cues at once. And yet, the result of that process, running across billions of years, across millions of species, producing solutions to problems we are only beginning to fully understand, is the most extraordinary visual gallery ever assembled. These are 7 animals so beautiful that the first instinct of every person who sees them is to assume they cannot possibly be real. They are: Number 1. The mandarin fish. In the shallow coral reefs of the Pacific Ocean, moving slowly through branching coral at dusk, the mandarin fish carries what is almost certainly the most vivid coloring of any marine fish in the world. The body is covered in swirling patterns of electric blue, neon green, and deep orange, outlined in black. A combination so saturated that marine photographers consistently report that no camera setting fully captures what the eye sees in person. The colors don't look enhanced in photographs. They look like the saturation has been manually cranked beyond what any real animal should produce. It hasn't been. What makes the mandarin fish's color genuinely remarkable to biologists is its mechanism. Most colorful animals produce color either through pigments that absorb certain wavelengths or through structural coloration, microscopic surface features that reflect light in specific ways. The mandarin fish does both simultaneously and additionally produces a true cyan through a pigment called cyanophore that is vanishingly rare in vertebrates. It is one of only 2 vertebrate species confirmed to produce blue color through actual pigment rather than structural light manipulation. It is also covered in a toxic, foul-smelling mucus instead of scales, making it one of the few fish in its environment that almost nothing wants to eat. The beauty and the toxicity are not unrelated. When you are that visible, you need a reason for predators to leave you alone. Number 2. The glass-winged butterfly. In the rainforests of Central and South America, the glass-winged butterfly moves through dappled light with wings that are, for the most part, simply not there. Or rather, are there but invisible. The membranes between the wing veins lack the scales that give most butterflies their color, leaving a window of clear tissue bordered by narrow bands of dark brown and orange that frame nothing but whatever is behind the butterfly at any given moment. The result is an animal that looks in flight like a pair of small, ornate frames carrying air. When it lands on a leaf, the wings reveal the leaf's texture and color through themselves. The butterfly's outline present and traceable, its interior simply absent. Researchers studying the wing structure found it is covered in nanoscale pillars of irregular height, structures that reduce light reflection off the wing surface to such a low level that the wing becomes, for practical purposes, invisible. The same optical principle is used in anti-reflective coatings on camera lenses and eyeglasses, arrived at independently by an insect in a tropical forest, refined by millions of years of selection pressure toward an animal that survives by being difficult to see. Number 3. The peacock mantis shrimp. The peacock mantis shrimp does not simply see color the way you do. You have 3 types of color receptor in your eyes, enough to perceive the full visible spectrum as millions of distinct colors. The peacock mantis shrimp has 16. It can perceive wavelengths of ultraviolet and infrared light completely invisible to human vision, and uses this system not to see more colors than we can imagine, but to process color information faster than any other known animal, identifying specific signals in its environment in a fraction of the time a human visual system requires. This animal lives in its own visual world that no human being has ever seen or will ever see, because no human sensory apparatus can access it. The animal itself reflects that world back. The shell combines iridescent blues, greens, reds, and oranges in patterns that shift as the viewing angle changes. Patterns containing, researchers believe, ultraviolet signal components meaningful to other mantis shrimp, but invisible to the fish and octopuses that might otherwise prey on them. It is a communication system hidden inside a color display that, from the outside, is already one of the most spectacular in the ocean. Number 4. The blue dragon sea slug. Drifting at the surface of the open ocean, small enough to sit on a fingertip, the blue dragon sea slug, Glaucus atlanticus, is one of the most improbable animals on the planet. The body is silver-white on top and vivid steel blue underneath, a color reversal that provides camouflage against both the sky above and the water below. The serrata, finger-like projections extending from the body in bilateral clusters, are tipped in deep blue-black, giving the animal the appearance of something painted rather than grown. What makes the blue dragon genuinely extraordinary is what it does with the things it eats. It feeds on Portuguese man-o'-war, siphonophores with venomous tentacles capable of serious injury to humans. And rather than digesting the stinging cells, it sequesters them into its own serrata, storing and concentrating the venom, then deploying it far more potently than the original animal could. The blue dragon does not produce its own weapon. It steals and upgrades the weapons of the most venomous prey it can find, carrying them in those beautiful blue-tipped fingers for use against anything that tries to eat it next. Beauty, in this case, is also armor. Number 5. The resplendent quetzal. In the cloud forests of Central America, the resplendent quetzal was considered so sacred by the Maya and Aztec civilizations that killing one was punishable by death. It was a symbol of freedom, of divinity, of a natural world offering something too extraordinary to be treated as ordinary. The male carries tail feathers extending up to a meter beyond its body, iridescent green so vivid that early European explorers described them as reflecting their own light rather than borrowing it from the sun. The chest is crimson. The back and head shift between green and gold depending on the angle of light. The entire bird, in full sun, appears to glow from within rather than from without. The iridescence is structural, produced by the microscopic surface architecture of the feathers rather than by pigment, meaning the color shifts with the viewing angle in a way that flat pigment never could. As the bird moves through dappled forest light, the green deepens, brightens, shifts toward gold, and returns, producing an effect that functions for both potential mates evaluating the display and human observers who have traveled thousands of kilometers to see it, as something that seems to defy the physics of ordinary color. It is listed as near threatened. The cloud forest it depends on is disappearing. Number 6. The panther chameleon. The panther chameleon of Madagascar does not simply change color. It restructures the architecture of its own skin. Beneath the surface, chameleons have a layer of cells called iridophores, containing nanoscale crystals arranged in a lattice structure. By contracting or relaxing the skin, the chameleon changes the spacing between those crystals, which changes the wavelength of light they reflect, actively engineering color change not through pigment, but through physics, by adjusting a crystal lattice in real time. Males of the panther chameleon species achieve some of the most vivid colors produced by any reptile. electric blues, neon greens, fire orange and crimson, and during territorial or courtship displays can shift through multiple colors across the body simultaneously, producing an animal that looks from moment to moment, like a living mosaic cycling through configurations that appear digitally rendered. The color serves communication rather than camouflage in most contexts, signaling mood, territorial status, and health to other chameleons who read the display with eyes capable of perceiving ultraviolet wavelengths the display almost certainly includes. Number 7. The blue morpho butterfly. The wings of the blue morpho butterfly are not blue. There is no blue pigment in them. The brilliant, metallic, almost electric blue that makes the morpho one of the most recognizable insects on Earth is produced entirely by the microscopic structure of the wing scales. A series of tiny tree-like ridges that interfere with light so specifically that only blue wavelengths reflect back toward the observer, regardless of the angle, with an intensity significantly brighter than any pigment-based coloration could produce. The structural nature of the color means it cannot fade. Morpho wing specimens in museum collections over 200 years old retain the same vivid blue as a living animal because the color is geometry, not chemistry. And geometry does not bleach or decompose. It also means the color functions as a signal across vast distances. A morpho in flight, in open canopy, catches and reflects sunlight with enough intensity to be visible from a kilometer or more away. Which is why in the Amazon, morpho butterflies can be spotted flashing above the canopy long before any other detail of the animal resolves. The animal underneath the blue is brown. Only one side of the wing is spectacular, but the spectacular side, when it catches the light, is one of the most arresting things evolution has ever accidentally produced. Here is what connects these 7 animals, and it is worth holding directly. Not one of these creatures is beautiful because evolution wanted beauty. Each one is spectacular for a reason: to attract a mate evaluating health and fitness in real time, to deter a predator that has learned to avoid certain patterns, to disappear into an environment that would otherwise expose it, or to communicate information through a visual channel that other members of its species can read, and the rest of the world cannot. We get to witness all of it, mostly as bystanders, mostly without understanding the signals being sent or the conversations being held. But the result, collected and looked at all at once, is the most extraordinary gallery any process has ever produced. And it produced it without a plan, without an artist, without any intention toward beauty at all. That is perhaps the most beautiful part of all.